Hello students, this is Channel Popat. We were discussing stress distribution. This is video part 2 for stress distribution. In previous lecture, we have seen basic analysis of geostatic stresses, Bosnia's assumptions and Bosnia's theory, as well as the effect of vertical load on a horizontal plane. Let us move further in this chapter. So let us understand vertical stress distribution on a vertical plane. We already know the formula now. Sigma z is equal to IB into Q by z square. Here, if we plot a graph through this equation of R by Z values, and if the Q is applied at here, concentrated load is here, and R is the radius of the graph, or we can say the point of application of stresses, the graph will go like this, and at the maximum value of sigma z, beta angle will be notable as it is 39.15 degrees. We can see variation of sigma z with r at constant depth z, as z will move like 0.25 to 5. R by Z will move like 4 to 0.2. Here, R will be taken as constant and Z is moving. In previous case, we have taken Z as constant and R was moving. Now, sigma Z and IB will vary like this in terms of Q. And at the maximum, beta will be 39.15 degree. In many exams, the beta angle is asked, and it is very much important for the analysis. So do remember that. So let us understand vertical stresses under rectangular area. Now, if this is a soil surface, the red square is again showing a soil surface, and on this, the smaller red square, the load is being applicable on this rectangular area. Now, what will be the stresses? That is the question, that is the explanation. Now, the area of that rectangle of that soil will be L length, B breadth, and Z depth, where M and N are defined as M is equal to B by Z and N is defined as L by Z. Now, if we talk about formula, sigma Z is given by this big wide formula, that is Q by 4 pi into bracket, and in another bracket 2mn under root m square plus n square plus 1 upon m square plus n square plus 1 plus m square n square bracket over into m square plus n square plus 2 upon m square plus n square plus 1 plus tan inverse into bracket 2mn under root m square plus n square plus 1 upon m square plus n square plus 1 minus m square bracket over, and whole bracket is also over. So this wide big formula is to be remembered for only and only vertical stresses under rectangular area. Let us move further. Westergards solution. So Westergaard also analyzed the problem of stress distribution under the concentrated load. He assumed the load as concentrated but the soil as in layers. So he assumed that in between clay there are thin layers of sand embedded in the soil. They are assumed as rigid and their thickness is assumed as negligible. They are closely packed to each other, but under the application of load, there will be no lateral strain assumed. There is only distribution of stress in vertical direction. So this is the model in which Westergaard has assumptions. Now, Boson has also given the stress distribution under concentrated load, but he assumed the soil as semi-infinite and isotropic, but isotropic is not actual condition, and Westergaard's assumption shows that he has assumed in layers the soil, and that is why it is non-isotropic and it is more close to the field. So let us understand Westergaard's analysis or Westergaard's solution. So here again the red square is assumed as soil surface, and point O is under the application of load, concentrated load, and other things are assumed as the same. Here things are to be marked like R is the radial distance of that point, capital R, that is the diagonal distance at sigma r or resultant, and z, that is depth of the point in which we are analyzing the stresses, and beta is the angle between resultant and vertical line. So Westergaard has given the formula sigma z is equal to 1 by 2 pi into under root 1 minus 2 mu upon 2 minus 2 mu upon 1 minus 2 mu upon 2 minus 2 mu plus r by z square and whole raised to 3 by 2 into q by z square. So this is the factor of Westergaard. Q by z square is almost common in each formulas by Boussinesq and Westergaard, but here mu, that is Poisson ratio. Now as the soil is assumed as elastic medium, the mu will be like in range of 0 to 0.5, but as it is assumed as elastic medium, the stresses under that will be very minimal, so it can be assumed as mu is equal to 0. So we can write sigma z as 1 by pi into bracket 1 upon 1 plus 2 into bracket r by z square raised to 3 by 2 and into q by z square. So now sigma z can be written as again IW into q by z square, where IW means Westergaard's coefficient, or we can say Westergaard's influence factor. So IW will be 1 upon pi in bracket 1 upon under bracket 1 plus 2 into r by z square raised to 3 by 2. So this is the equation given by Westergaard. Let us move further. Boussinesq's and Westergaard's theories for uniformly loaded circular area. Now we are talking about circular area. We have previously talked about concentrated load as well as loads on rectangular area, but this is new to us. Let us understand this. So this is the point which is under application of load, and z is the depth, r is the radius, and this is the point where we are finding the stress application. So Boussinesq analysis gives us the formula sigma z is equal to q into under in the bracket 1 minus in the bracket 1 upon 1 plus r by z square whole bracket raised to 3 by 2 and bracket is over. Same way the r and z, whichever was assumed as before, as r is equal to radius of circle, z is equal to vertical depth, and small q, that is intensity of load per unit area. So q will be in the unit like kilonewton per meter square, newton per mm square, like that. It is intensity of load per unit area, right? And Westergaard has given the different formula which is slightly different to that. That is sigma z is equal to q into bracket under the bracket 1 minus in the bracket 1 upon 1 plus 2 into r by z square whole raised to 1 by 2 and bracket is over. So these two are fundamental formulas to find out uniformly loaded circular area stresses. In the numericals, in examples, there are many examples have been asked from this. Let us move further. Newmarks influence chart. So Newmarks influence chart, it is very much simpler concept. If you have seen a drop getting dropped in a bowl of water or a lake, it will get in waves, in round radiating lines, right? So it is based on concept kind of like this. Now Newmark influence chart can be utilized in under the any shape of rectangular or circular, any shape of loading area, and under any depth z. It is based on the concept of that the vertical stress at a point below which the any shape of any area of loading is applied, and the radiating lines below the loading will be shown, and these lines will be showing as a concentric lines, and these will be showing stresses. Now each sector of that line will be having same vertical stresses. It is designed and it is assumed like that. Let us understand through this figure. Now O is the center of two circles. Here we can see two circles having R1 and R2 radius. Here sector number 1 and sector number 2 can be seen. Every sector will be having same vertical stress value. Now this blue one is called inner circle and this green one is called outer circle. Equation given by Newmarks influence theory is sigma z by 20 is equal to q by 20 in bracket 1 minus in bracket 1 upon 1 plus r1 by z square and whole 3 by raised to 3 by 2. Here q is intensity of loading per unit area and 20. Why 20 is here? Because every circle is divided in equal parts and 20 equal parts. So O and circle, inner circle having radius r1 will be divided in 20 equal parts, and every equal part will have these kind of stress values. Let us assume an arbitrary value. Let us say sigma z is equal to 0.05 q. It is also known as Newmarks influence factor. Now putting sigma z as 0.005 q, it will get the solution r1 by z is equal to 0.270. Now what does it mean? It is very much simpler and deeper to understand that. Now if we are assuming sigma z as some value like influence value, that is 0.05 q, so r1 by z is coming 0.270, so r1 can be taken as 0.270 z. So at every point wherever 0.270 z is coming, at every radius the value at every peripheral value will be same as 0.05 q. So that is the basic understanding. Every point will have same value of the stress if the condition is fulfilled. Now let us assume another circle, that is outer circle, and let us assume double amount of stress. For that is sigma z is equal to 2 into 0.05 q. Putting the value in the equation, I am getting solution r2 by z as 0.40. Now it is showing r2 is equal to 0.40 into z. Now if I am assuming double the stress, where it will be acting? It will be acting r2 is equal to 0.40 z. So if the depth is assumed as something, let us assume depth as z is equal to 5 centimeter and influence factor is taken as 0.05 q. Then value of radius of every circle, like from circle number 1 inner circle, outer circle, outer third, outer fourth, like that, it will look like this figure, and radiuses of these circles will be like this. Number of circle number 1 will be having radius 1.35, and it will get up to 10. Now at 10th there will be infinite, because equation limits up to that, and we cannot draw 10th circle here. Circle for number 10 cannot be drawn here. So this is Newmarks influence chart theory. It will show every equal stress point throughout the soil. Let us discuss some points to be noted while using Newmarks influence chart. First of all, in every circle, in every unit area, all the fractions should be taken into account and properly in account for this. Second point, for Newmarks influence chart method, that is, you should consider the 10th circle if the plan area permits you to draw the 10th circle. Do not stop up to 9.5 circle. If it permits, you should go to 10th circle. The third important point to use Newmarks influence chart is that you should take care of the change of plan area. If the loading area is changed, you should draw a new plan. And the fourth most important point to use Newmarks influence chart is that the point P, wherever you are finding stresses that may be within the loading area or maybe outside the loading area, the method will remain same. So these are basic points should be noted and keep in mind throughout when you are using Newmarks influence chart. Let us keep our session up to this. Thank you.